Welcome. Today, we are taking a journey through the layers of the oldest light in the universe, the cosmic microwave background. We will look at the raw data captured by space telescopes and see how scientists stripped away massive layers of cosmic noise to reveal the ultimate secrets of our creation. The absolute view. At a scale from 1.2 to 4.2 Kelvin. This is the universe at first glance. On a broad thermal scale centered around the cosmic average of 2.7255 Kelvin, the sky appears completely uniform. It is a featureless, solid color. This initial view showcases the astonishing, large-scale homogeneity of our cosmos. Narrowing the focus. At a scale from 2.55 to 2.85 Kelvin. We zoom in by a factor of 10, narrowing our temperature window. Even at this scale, the cosmic background looks perfectly smooth. The dynamic differences are still hidden beneath the surface, proving that the ancient light from the early universe is incredibly well distributed. The Cosmic Dipole. At a scale plus minus 3.36 millikelvin. By isolating the first and largest feature, a massive yin-yang pattern emerges. This is the cosmic dipole. One side of the sky looks slightly warmer, while the other looks colder. This is not an intrinsic property of the universe, but a kinetic effect caused by the motion of the Planck satellite through space. Removing the dipole. At a scale from 2.724 to 2.727 Kelvin. Now we apply our first major correction. By mathematically subtracting the massive movement effect of the dipole, a new feature takes over the center stage. A bright, chaotic band cuts straight through the middle of the map. The heavy microwave emissions of our own Milky Way galaxy. The galactic foreground. At a scale from 2.72535 to 2.72565 Kelvin. Zooming in even closer, we enter the realm of microkelvin fluctuations. Here, our home galaxy completely dominates the view. The glowing interstellar dust and accelerated electrons of the Milky Way act like a thick layer of smog. Scientists must clean this layer to see the beginning of time. The primordial echo. At a scale from 2.725485 to 2.725515 Kelvin. In this final correction step, scientists carefully mask and remove the galactic foreground. What remains is the genuine cosmic microwave background, a snapshot of the universe when it was just 380,000 years old. Notice the size of these spots. They average exactly 1 degree across. The physical size of these fluctuations provides the ultimate geometric proof that the fabric of our space is completely flat. The seeds of matter. Fluctuations are tiny, just 1 part in 100,000. These ripples in the early plasma gravitated over billions of years. They formed the vast network of galaxies and stars we see today. The flat universe. The precise size of the CMB fluctuations confirms Euclidean geometry at a cosmic scale. If space were curved, these spots would appear larger or smaller than exactly 1 degree. A tribute to the engineers. None of this would be possible without the precision the engineers built the Planck satellite. Operating at 0.1 Kelvin above absolute zero. For a time, this made the satellite the coldest known object in the universe.